And the second part of math class today, while you're working, you might also want to take out your cheat sheet and spend some of class time today just adding this stuff together. Because what we did before today was distribution, where you had a number out in front and that number distributed to both, and we got 5x plus 15. And we have to do this in algebra because before you had order of operations, you could actually put things together inside your brackets, because you would do brackets first. But now that we have algebra, we can only put things together if they're like terms, and sometimes what's inside the brackets.
5 minutes late.
Okay.
No, 10 minutes late, because I was that much away from my class. You know what you would do, maybe you can go check on
I will, yeah.
And I have no idea if it was supposed to quit after an hour or the train started.
Okay.
No, it's wrong. It'd be fine if they showed up during the break.
Well, yeah, I told him.
This is just time, right?
You asking me?
Okay, you should be positive, not negative. Those little dots? Yeah, I know, I was doing this when I did it.
Yes.
Go quickly down on this.
Like, what do you
But I'll show you guys first the idea.
No.
And the idea is now, with two sets of brackets, we draw a set of arrows from the first one and a set of arrows. It's like extra distribution. The first term gets distributed and the second term gets distributed. For the second one, this x would get distributed to all three of those. And the 4 would get distributed to all three of those. And if you have something squared, remember squared means multiply by itself. So if we rewrite it as multiply by itself, we're like, this is the same as a binomial times a binomial. So we multiply all of these together. In particular, in the binomial, sometimes you'll hear teachers say FOIL because the first arrows represents multiplying the first ones. The second arrow is the outside ones. The third arrow is the inside ones. And when you multiply the last ones together for the fourth arrow, so sometimes people use FOIL to remember you have to do 4 arrows. Some people just say, I just remember drawing the arrows. Okay? But then you'll get teachers who say, hey, you made a mistake here. Remember to FOIL. And then they're talking about all of those arrows for distribution. And then you always have to simplify, which means combine your like terms.
Is that
Dave, you capturing this?
no.
So, what I want you to do, while I go check downstairs on the contest, is draw the arrows and simplify this one. Draw the arrows and simplify this one. Draw the arrows, simplify, and keep the 2 out in front. And then after, you're going to have to distribute the 2. And draw the arrows. Okay, so we're going to, you've got a lot here you can try on your own. We'll see how far you get by the time I get back. I'll pause the video here.
So hopefully we all had a chance to really give those a try. If you didn't try, that's something we need to be working on. Like you won't know if you just think, hey, someone tells you, and then you do. It doesn't always work that way. You gotta figure it out. You gotta think about what you've learned and give it a shot. And then that way you're like, okay, I'm on it. You either build confidence or you're like, whoa, I didn't get it. Where's my questions then, right? So for binomial times a binomial, as discussed, we can look at FOIL, but I do like how Mr. JR showed that it's just this times this and this times this. So you really distributing this one thing to both, right? Which is what we were doing yesterday with a monomial times a binomial. Do you guys see that? So then it's just like, well, FOIL can get a little bit complicated for some. For me, I like just knowing that I have to distribute both of these. So this -6 will need to go to the y and the 9. So we start step by step. I always like to think of it as you do your signs, then numbers, then variables to each of these things. So the signs, which I'm talking positive times a positive or negative times a negative, those are same signs, they equal positive. So let's go here. I've got a positive times a positive. What would that be? What would a positive times a positive be?
Positive.
It's a positive. What would 1 times 1 be? Remember, with our math
One.
goggles, we see it's really 1y, right? So what would 1 times 1 be?
1.
Good. So do I need to write the 1?
No.
All right. What would y times y be then?
Y.
Y. But remember, there's an exponent here, and we got to think of our
Y.
power laws.
Y squared.
So it'd be y squared because when we multiply two things with the same base, we add the exponents. Do you remember that? So 1y times 1y would be y squared. Then we go to y, positive y, times positive 9. So positive times a positive
So it'd be just 9.
Sure, sign first.
would be a positive. I'm just taking care of the sign. Here how I'm flowing this through. What positive times a positive,
Positive.
positive. Y times 9,
9.
9y. And then we move on to the next one. Negative times a positive. What would that be?
Negative.
Negative. 6 times 1.
6.
And then we still have the y.
6y.
Negative 6y. And we've got a negative times a positive.
So negative.
So now we're doing right here, so it'd be a negative. And so negative 6 times positive 9, what would that be? This one's a little bit trickier.
54.
54, very good. Now, are we done? Why aren't we done?
Because there's like terms.
Are there like terms here?
Yes.
9y and 6y. Notice how I'm circling to take the sign with it. So I keep my y squared, but I've got positive 9y's and I take away 6y's. What do I have? Positive 3y minus 54. I can't do anything with because there are no other constants. Is this done?
Yes.
Fully simplified? We can box or circle our answer. Are we good there? Did anybody try that and get that? Perfect. Perfect. Good. And how many of you tried the next one? Okay.
No.
So now instead of all of it at once, I'm just going to go step by step. What am I doing with this m?
Putting the arrows to the other end and make them 12.
Perfect. So let's just take care of just that. What is positive m times positive m?
And to
M squared. What is positive m times negative 12? So I think positive times negative is a
negative. So,
negative. 12 times 1. Perfect. Okay, so we take care of those two things. Now what are we doing? Distributing the
5.
positive 5 to the m and the negative 12. So I've got positive times a positive is a, yep, and 5 times m is 5m. I've got a positive times a negative.
Negative.
It's a negative. What is 12 times 5?
12 times table.
We got 60. What would be another way if I didn't know?
12, 24, 36.
What would be an easy way of doing 12 times 5? Can I do 10 times 5? What's 10 times 5?
Me.
And then 2 more groups of 5. Perfect. Is this finished?
No.
What do I have left to do?
Like for the
Like terms, what are they?
-12 and -5.
Negative 12m and 5m. So I've got my m squared. What's negative 12m plus 5m? Negative 7m.
Guys are getting good at your positives and negatives.
Guys, if you got this answer and you tried it, bravo. I think we're gonna pass.
Oh yeah? No, you can keep going. I was gonna show one extra thing on here that you might find interesting. So you had to do 5 times 12, right? And some of us don't know our times table for 12. Perfectly fine. You are allowed, and what Mr. Sherk said was, in a way, you were distributing. He said, what's 5 times 10? And what's 5 times 2? He actually was doing this. He was doing, well, 12 is 10 plus 2, and if I distribute, that's easier math. 5 times 10 is 50. 5 times 2 is 10. Are those like terms? Absolutely. Heck, I could even get you to do some complicated stuff, like 8 times 17 now. Oh my goodness, I'm pretty sure you don't know the answer to that. But if you think of 17 as 10 plus 7, 8 times 10, that's 80, that's easy. What is 8 times 7? That's still not an easy one.
Think about it as 8 times 8 is 64, so you can just take 64 minus 8, which would be 56.
56.
Love that, JR.
All right, there you go.
Love that. Just thinking about that. I didn't even put that together
Yeah, sometimes sometimes we do that. We do that math all the time in our heads,
in our
and we
head.
don't realize that you're really distributing.
Am I moving at an okay pace?
Yeah.
Yeah.
Everybody okay? Do we all have this down?
A lot like you.
Okay. Oh, do we want?
No, it's fine.
Those are good things to add though. Okay, this one a little trickier, okay? Because we have that number 2 outside.
He has a choice. You could either.
Yes.
We'll see what Mr. Sherk prefers.
Okay. This could, you know what? I'm gonna just trust my gut on this. I might distribute this 2 first. And then I'd have to ask myself, it would still have to be, if I distribute this 2 in to the x minus 3, would it be fair to say that whatever I get from that still has to all multiply by this? Can we agree with that?
Yeah.
So I could do it, here would be one way, step or just, yeah. Oh, yeah. I'd have to figure out whether I want to show both ways, but let's just go through this. So distributing, does this look like yesterday's stuff?
Yes.
Yeah, monomial,
You can ask.
which is just one term,
At that time.
times a binomial. So 2 times x is,
We're dividing, so divide the numbers, can you divide 6?
and 2 times negative 3 is negative 6. You guys really are getting good. Now, what I'm gonna do is, do you see how that answer is like this? I'm gonna throw it in a bracket,
More sets.
and I'm gonna multiply that by x plus 2.
So what do you guys do with the 2x?
So I distributed the 2 in first, and then I put that answer, because now what is it? It's a binomial times a binomial. So that's why I would put it in a bracket, so that you could see that all of this answer had to be multiplied by this binomial. So now, what would I do here? Time to distribute the 2x to both terms. So what is 2x times x?
That's fair.
2x squared. You guys are on fire. Mr. JR has really sharpened you guys up. And now I've got a 2x times 2.
Negative 12.
Well, not there, we're not.
Not there yet. what is 2x times 2
4x.
plus 4x? Perfect. Now on to the second term of the binomial. -6 has to be distributed. So I've got a negative times a positive. What would that be? Negative. What is 6 times x?
6x.
6x. Thank you, Brandon, for your participation. I've got negative times positive. Negative. And what's 6 times 2? Perfect. Are we finished? We are not fully simplified. We have like terms here with x's. And again, just repeating, always good to reiterate what makes like terms like terms. You would say 2x squared. I've got 4 x's and I take away 6 x's.
Negative 2x.
I have negative 2 x's minus the 12. Are we good there?
Now, something I'm noticing is a good thing. There are people that are responding, and the people that are responding are people who are feeling confident. Okay? Some of you aren't responding. Some of you, that's your nature. But you should be checking if someone else responded, is that what you got? You can gain your confidence, but you want to try to get that answer in your head before someone says it out loud. Because that way you're practicing as well. You can check if you're getting it right or not.
Yeah. And cuando el positivo tiene
Do you guys, it's show of hands who would like to see another way of doing that question? Do you feel like you understood this clear, or would you like to see another way of doing this question? The other way? Okay, so I'm not sure if I'm supposed to save this, but do you guys everybody have this down? So can I just erase that? Okay. Now just doing it another way, we're just gonna look at the binomial times the binomial. So that's what we just have been doing in the previous questions. So we would just take this. Now, I'm not as comfortable this way, so this is great for me too. But what is x times x? X squared. What is x times 2? Positive 2x. I'm just going to kind of cruise through a little bit more because this is the second way now. I've got my -3, and I'm going to distribute that. So, again, I love to draw the arrows. I think the arrows are key for starting out. But -3 times x would give me a -3x. And a positive 2 times -3 would be -6. Can we agree that we've just sorted all that out?
Yeah.
And can we agree that we still have the 2 there? So why don't we just say that that 2 has to be multiplied by everything in here? Is that fair? So then I would write this 2 outside. Now what do you think that means?
You have to distribute
To one term, 2 terms, or all of them?
all
I gotta distribute this 2. Much like yesterday, monomial times a monomial could be, or a binomial, could be a trinomial, could be a polynomial, 4 or more terms. And in this case, we have a 4-term polynomial, and it has to distribute to every single one of these. So I've got positive 2 times positive x squared, 2x squared. I have a positive 2 times positive 2x.
4x.
I have a positive 2 times a negative 3x. Positive times a negative. Negative 2 times 3x. Perfect. Positive times a negative. 2 times 6. We get the same. Are we done?
No.
Like terms. Like terms. Leaving me with 2x squared minus 2x minus 12. There are two ways of doing it.
The funny thing is, I started with this one, not the other way you should.
That's fair.
I did this one first and then I wrote down just on the side the
Yeah.
other way.
They're both correct ways. You wanna take this off?
Sure, I can do the last couple.
Perfect, thank you.
Awesome.
Well, that was fun.
I'm gonna go back and do. I'm gonna make up one before we do this one, and introduce. So if you had x plus 2 times by x plus 3, my favorite is to draw the arrows. So I'm gonna just do the answer quickly with the arrows. You would have x times x, which would give you x squared, x times the 3, plus 3 positive times positive plus 2, and 2 times 3 plus 6. And so you would combine your like terms, and you would get x squared plus 5x plus 6. Now, sometimes in your homework, they'll show this with algetiles. And sometimes we can solve this with something called the chart method. Some people really like the chart method, especially for the next thing. Notice you had 4 arrows. The chart method looks like this. If you have x plus 2, you would write x and plus 2. And if multiplied by x plus 3, you would have x and plus 3. And you make a chart, and this chart has 4 boxes. Those 4 boxes represent your 4 arrows. How do you fill in the first box? Well, that's the x times x box. Ooh, x box. X squared. And the x times 2, that would be 2x, and it would be plus. And x times the plus 3, that will be a plus 3x. You don't have to write the plus sign there, but you'd have to write the negative sign if it was negative. And plus 3 times plus 2, that's 6. Do you see that these are like terms? And we combine them together to get 5x and write everything out. We get the same answer. So some people like this chart method because when we get to a question like this one, oops. I skipped it. Where did it go? Here. When we get to a question like this one, there are a lot of arrows. This arrow, this arrow, this arrow. I mean, me personally, and probably Mr. Sherk as well, still like the arrows. So if I do arrow by arrow, x times x squared, we have to use our exponent laws, x cubed. X times negative 3, sign first, that's going to be negative. 1 times 3 is 3. X times x will be x squared. Third arrow, x times 5, it's going to be a positive 5x. Fourth arrow, 4 times x squared will be positive 4x squared. The next arrow, 4 times the negative 3, positive times negative, 4 times 3, 12.
It's a grind.
And x, and finally positive times positive, positive, and 4 times 5, 20. Wow, we have 6 things. And sometimes it can be easy when you're doing your mental math to get lost. Which arrow was I on? Which arrows have I done? Then we look, do we have any like terms? I have with x squared like terms. And I have with x's like terms. So I can put everything together. I still have just an x cubed. But minus 3 plus 4 will end at plus 1. And I don't have to write the 1. Plus 5 minus 12. Where would that end up? Positive or negative? You're at plus 5, you subtract 12. Negative 7. And we still have the plus 20. So some people like to do it with the arrows and some people like to do it with the chart. How big is the chart? Well, we have x and plus 4. And here we have x squared, a minus 3x, and a plus 5. And you have 6 boxes to fill.
It really is clear to see that way.
And when you fill in, the nice thing about the chart method is that you don't forget where you're at. You don't forget which ones you've done and which ones you haven't done. The reason why people don't like the chart method is it takes so much space in my notes. I mean, it's bigger. The arrows seem smaller. But you get exactly the same answer. Look, x times x squared, x cubed. X times minus 3, minus 3x squared. X times 5, 5x. 4 times x squared, 4x squared. 4 times negative 3, negative 12x. And 4 times 5, plus 20. Check it out. We still have, I'll circle the green ones. You see that they're exactly the same as the green ones that were circled there. I'll underline in purple. You see that those underlined in purple match up to what I underlined in purple on the other side. And then when you write your answer, okay, we've got an x cubed. These two can be put together. 5x and the minus 12x can put together, and I still have the plus 20 to get my final answer. We're going to continue with this on our notes tomorrow, but I'm going to give you the last half an hour to work on the assignment, and we'll get time to work on the assignment again tomorrow. But we'll hand it in at the end of class, just so that we have everybody's copy. The one thing on the assignment, if you get to the ones that are squared, you can do them, just really remember that squared means multiply by itself.
And I would just do
I would do that as my first step and then draw my arrows. Awesome.